starting in with the question format. We're going to have a video for each of our recorded videos. We're going to have questions corresponding to each of those. The way that this is going to work, I'm going to read the question, read out each of the answer choices, pause for a moment. You can feel free to pause the video, answer the question, and then we're going to go over the answer and explain why it is the answer. Cool? Okay, question 1. Which amino acid does not have a chiral carbon? Glycine, alanine, valine, or leucine? The answer to this question is going to be glycine. Glycine, first we remember a chiral carbon. What does that mean? Chiral carbon refers to a central carbon that is bound to 4 unique molecules, 4 unique things. Glycine, because glycine's R group is just a simple hydrogen, it already has another hydrogen on the other side, therefore it does not have a chiral carbon. Glycine is one of our smallest amino acids. Next, question 2. What property makes all amino acids amphoteric? The fact that they have a chiral carbon, the ability to form disulfide bonds, the ability to act as an acid or a base, or the aromatic ring structure. The answer to this one is going to be the ability to act as an acid or a base. So amphoteric, if we remember the actual structure of our amino acids, right here has our central carbon. It has an amino group, which has the ability to donate hydrogens, which is what we define as an acid, or the carboxyl group, which can donate the OH hydroxyl group, that which is our definition of a base. Which 2 amino acids are purely ketogenic? Leucine and valine, leucine and lysine, lysine and methionine, tryptophan and tyrosine. When we talk about the ketogenic amino acids, let's think about our mnemonics that help us remember all of these. Our mnemonic for the ketogenic amino acids is Lucy lies to get the keys. So we have Lucy and lies, which is our leucine and lysine are our purely ketogenic amino acids. We can see leucine right here, but valine, what is valine? That is one of our branched chain amino acids because we live on a branch. Methionine is our sulfur-containing amino acid. To be an MCC, you need sol. And tryptophan and tyrosine is your pal Tyrone, trips you in the ring. Those are our aromatic, 2 of our aromatic amino acids. Next, what is the function of carnitine, which is derived from the amino acid lysine? Transports fatty acids into the mitochondria for beta oxidation, synthesizes glucose during fasting, forms disulfide bonds in proteins, or acts as a neurotransmitter. The function of carnitine, we'll see carnitine again in a future explanation, but understand that it comes from the amino acid lysine, one of our ketogenic amino acids, and its job is to transport fatty acids into the mitochondria for beta oxidation. Question 5. Which amino acid contains an indole ring? Phenylalanine, tyrosine, tryptophan, cysteine. So the indole ring, specifically, we know if it's a ring structure, those are our aromatics. So your pal Tyrone trips you in the ring. So we can eliminate cysteine as an option, and we need to remember what an indole ring is. An indole ring is a structure of 5-point structure instead of the 6-point structure. So we go here and we look at our aromatics, and we see phenylalanine and tyrosine have their 6. Tryptophan has this 5-ring structure. This is a secondary ring to everything. So our answer is tryptophan. It has our indole ring structure. Which of the following is an aromatic amino acid? Methionine, tryptophan, cysteine, and valine. Let's go through each of these. Methionine. What type of amino acid is methionine? These are mnemonics, our MCC. You need sol. This is our sulfur-containing amino acid. Tryptophan, your pal Tyrone, trips you in the ring. This is going to be our correct answer. Let's keep going. Cysteine, however you want to pronounce it. Again, our MCC, this is a sulfur-containing amino acid. Valine, we live on a branch. This is our branched chain amino acid. Remember, leucine, isoleucine, and valine are our branched chain amino acids. Which bond links 2 cysteine molecules to form cysteine? Hydrogen bonds, ionic bonds, peptide bonds, or disulfide bond? So when 2 cysteine molecules are bound together, this is going to be a disulfide bond. We see this a lot in insulin, is the main structure that we get asked about when we talk about our disulfide bonds. And as well, cysteine and cysteine are both sulfur-containing amino acids, so we know, if we connect those to sulfur, it is a disulfide bond. Question number 8. The branched chain amino acids include which of the following? Phenylalanine, tyrosine, tryptophan, leucine, isoleucine, valine, methionine, cysteine, cysteine, aspartic acid, glutamic acid. We have our live on a branch is our leucine, isoleucine, and valine are our branch chain amino acids. What is the mnemonic for phenylalanine, tyrosine, tryptophan? They are our ring structures. Say your pal Tyrone trips you in the ring. Methionine, cysteine, cysteine. What is our mnemonic for this? To be an MCC, you need sol. Those are sulfur containing. Aspartic acid and glutamic acid. These are our acidic amino acids. It's acidity of as and glutes. Question 9. What condition is associated with an inability to break down branched chain amino acids? So we think branched chain amino acids. Our options are alkaptonuria, maple syrup urine disease, phenylketonuria, and Marfan's syndrome. The answer to this is going to be our maple syrup urine disease. The way that I like to remember this, maple trees have branches, so we are branch chain amino acids is what we struggle to break down. Phenylketonuria, this is our PKU. This is an inability to break down the phenylalanine. Should be here. There we go. Deficiency of the phenylalanine hydroxylase, phenylketonuria, PKU, so we can't break down phenylalanine. That's the big one that's going to be asked. Marfan syndrome we'll talk about more in pathology. Marfan syndrome is a genetic disorder in which it's a connective tissue disorder that produces long fingers, makes you super, super tall, as well as is associated with aortic or thoracic aneurysms that can potentially rupture. A dissecting aortic aneurysm. Question 10. Aspartic acid and glutamic acid are classified as blank. Basic amino acids, neutral amino acids, acidic amino acids, aromatic amino acids. Of course, our aspartic and glutamic acid really gives it away. They are our acidic amino acids. Question 11, excessive aspartic acid, as found in aspartame, can lead to which of the following? Neurotoxicity, hypoglycemia, muscle weakness, or fatty acid buildup. So aspartame can actually break down, contains aspartic acid, but it also is related to ammonia. If we have too much ammonia, we get neurotoxicity in the body, have damaging effects on the brain. Question 12. Which amino acids have the greatest positive net charge at normal blood pressure, at normal blood pH? Acidic amino acids, aromatic amino acids, basic amino acids, or sulfur containing amino acids. This specific question we didn't go too deep into while we were going over the lecture material. It is our basic amino acids. The basic amino acids have a positive net charge at our normal blood pressure. Question 13. Which amino acid is the limiting amino acid in wheat? Lysine, tryptophan, methionine, or cysteine? Again, this comes from that specific table in that amino acid section. Questions don't often come from here, except for an exception to talking about eggs. In this case, lysine is the amino acid that we see is the limiting amino acid from wheat. What is the limiting amino acid in legumes? Sorry, lysine, tryptophan, methionine, or valine. In legumes, it is going to be tryptophan as our limiting amino acid. Again, very rarely asked, but good practice. Which amino acids are sulfur containing? Methionine, cysteine, cysteine, phenylalanine, tyrosine, tryptophan, aspartic acid, glutamic acid, or leucine, isoleucine, and valine. we think about our mnemonics. For a sulfur-containing acid to be an MCC, you gotta have sol. That is our MCC. Methionine, cysteine, and cysteine. Question 16. How are disulfide bonds significant in proteins? What do disulfide bonds actually do? A, they stabilize protein structure. B, they transport fatty acids. C, they contribute to amphoteric behavior. Or D, they enhance protein solubility. The purpose of those disulfide bonds is to stabilize the protein structure. Question 17. Which amino acid is a precursor to carnitine? Remember, carnitine is responsible for helping to bring fatty acid chains from the cytosol into the mitochondria. So it's dealing with fat. And when we're talking about fat as an energy source, we often refer to using just fats as energy source. We can convert them into ketone bodies. So we have, let me read the whole question. Which amino acid precursor to carnitine? Lysine, leucine, tryptophan, or cysteine. We're going to be talking about a ketone, ketogenic amino acid. So Lucy lies. Get the keys. So immediately our answer choices are between lysine and leucine. We have a 50-50 chance. We just want to remember lysine is our precursor to carnitine. What is the unique structural feature of aromatic amino acids? Sulfur-containing side chains, branch chain structures, ring structures in their side chains, or high positive net charge. Talking about our aromatic amino acids, these are our ring structures in the side chains. Which amino acids are essential among the aromatic group? Tryptophan and tyrosine, phenylalanine and tryptophan, phenylalanine and tyrosine, tyrosine and cysteine. So remember our essential amino acids. We have private Tim Hall represents our essential amino acids. The P and one of the T's represents phenylalanine and tryptophan. The reason why it is not tyrosine, you can see the common denominator between all three of these are tyrosine, and that's because phenylalanine can be converted into tyrosine. So as long as we have phenylalanine, we can produce tyrosine. So we don't need tyrosine in our diet. Question 20. What phrase helps remember the aromatic amino acids? So aromatic. Live on a branch. Lucy lies to get the keys. Your pal Tyrone will trip you in the ring. A city of ass and glutes. Live on a branch. These are our branched chain amino acids. Lucy lies to get the keys. Those are our ketogenic amino acids. Your pal Tyrone will trip you in the ring is our aromatics. The city of ass and glutes is our acidic amino acids. Question 21. Which amino acids are limiting in maize? Specific maize is another word for corn type products. Lysine and tryptophan, methionine and cysteine, aspartic acid and glutamic acid, leucine and valine. The answer is lysine and tryptophan. Again, not asked very commonly, but just reviewing it now, just in case it does pop up. What phrase helps remember the limiting amino acid in pulses? Nutritionists lie about wheat. A maze will lie and trip your brain. Don't trip on your leg. Taking meth causes heart pulses. Easy one to find out. Taking meth causes heart pulses, referring to methionine. Methionine is that limiting amino acid in pulses. Which amino acids are basic? Lysine, arginine, histidine, aspartic acid, glutamic acid, methionine, cysteine, cysteine, phenylalanine, tyrosine, tryptophan. Our lysine, arginine, histidine are our primary basic amino acids. Question 24, which amino acid is found in aspartame? Lysine, aspartic acid, methionine, or cysteine? This is our aspartic acid. And what's important about this, if we take too much aspartame, can be neurotoxic is our big thing to remember. Last question, question 25. What determines the function of an amino acid? The chiral carbon configuration, the R group / side chain structure, the ability to form disulfide bonds, or the aromatic ring presence. That's going to be our R group or side chain structure. Determines the function of our amino acid. Okay, this concludes the 25 practice questions. There are in the materials many additional questions, not necessarily sorted in this same way, but the more practice questions that we can do, as well as following along that material in the form of practice questions, the more we are forced to recall the information, and the better chances we are at answering questions on the board exam. And we'll move on to the next chunk of material.